Okay, so that whole thing, what this 3.1 section is really all about is being able to recognize, like I said, the degree of a polynomial and then recognizing the ending behavior. So if I look at something, I mean, something like this probably isn't that hard. You can see that it has a degree 5. I don't know what the zeros are because it's not factored, and that's where we're going to go in during this next week. Um, I do know the leading coefficients right there is 6. So it's always the coefficient, the number in front of the degree with the biggest term. Where it's a little more interesting here, let me erase this. And because of this, because of the 6x to the 5th, I know the leading term is what's gonna rule the function. So there's a lot of stuff going on in the middle. We don't know what it is, but I know way out here, big numbers, right? I'm way out here, big number, because it's an odd power. I know it's going to look like that. And then on the left, way out at a negative number, it's going to go down like that because it's a 3rd degree or 5th degree equation. So if I had to try to answer this stuff with that question, I would just have to say as x goes out to negative infinity, y goes down to negative infinity. And I know this without graphing it just because of that leading term. And then this one, as x goes out to positive infinity, that's supposed to be an arrow. Y approaches positive infinity. Okay, this should be negative infinity. I don't know why I wrote positive infinity. All right, so as x goes out to negative infinity, y goes down. As x goes out to positive infinity, y goes up. If it's a negative, like do we have a negative odd power? Number 12, odd power, well, I know it's just going to be reversed because it's a reflection around the x-axis, right? Boy, it's funny how it all ties together, huh? So that's going to look something like that. And then this arrow notation, as x goes out to negative infinity, y goes out to positive infinity. As x goes out to positive infinity, y goes down to negative infinity. Okay. So then where does it all get even better? I looking at number 16. Well, I see there's 3 zeros. What's the leading term going to be? Well, we're not expecting you to FOIL that all out. Not expecting you to use photomath to expand it. All you've got to do is look at we know the leading terms come from multiplying these 3 terms to get these 3 expressions together. So what is that? 12x to the 3rd. And I don't care about the rest of it. Just that much will tell me, or it actually tells me a lot. I know that it crosses the x-axis at negative 1/3, so right about there. Crosses the x-axis negative 1, so right about there. Crosses the x-axis negative 1 1/3, right about there. And I know in the end, and I know the y-intercept. Why do we do that? So the y-intercept, that's 0, that's 0, that's 0. So 1 times 1 times 3 is 3. So across the y-axis right there. So I know this graph's going to look something like this. It's going to come down like this. It's going to pass through that point there, turn around, head up there, turn around, head down there. Now I don't have those turnarounds right. We need more math to do that. But I know that's the general form of that equation just by looking at the zeros, where at the factors, just looking at that leading coefficient. So that's why this is important. Simple, yes, but powerful. Okay. So I guess that's a long enough video, but that's why this is important. It is not just an easy, not just play, okay? Not just busy work.